How's that, guys? That's better. Hopefully the sun will remain away long enough that you guys can see the projector, but if not, feel free to take a look, to avoid my eyes and look at the slides from the side there. My name's Mark Williams. I'm a penetration tester, and I'm here to talk about antivirus evasion, or more accurately, I'm here to talk about my adventures in malicious software. I say this because it's not really antivirus evasion. I'm not going to drop any new technique or anything like that, but it's something that I've been working on for quite a while now in terms of just seeing what we can do with antivirus and things we can get away with without being pinged. So I'm a penetration tester. I hack computers for a living. That's what I do. And I have to drop malicious software on other people's machines. So antivirus is something that gets in my way quite a lot. I started out with this idea that I really like malware, and I want to develop something that can assist me not only in my day job but in my learning about how systems work. Because that's the big thing with antivirus. It's this black box security thing. We all install it, we're all told that we require it and that it's going to keep us safe, but we don't really know how it works. So we might hear some buzzwords like signature detection and behavior analysis, but we don't really know if it's even doing anything. When it finds something, it makes a really big deal out of it, and antivirus is like, ha, look, I found something and it was bad, I kept you safe. But we don't know that it's finding everything, and indeed my day job is to kind of sneak past this. So my adventure followed roughly this line here. Why evade is easy. I'm a penetration tester. I have to install this software, the tools that are required to do my job. But when it actually came to learning how to evade and trying to apply these techniques, I tried to keep things scientific. So I wanted a control group, a file that I knew was malicious that I could alter in such a way to see if I can get a known malicious file through antivirus. And there's some techniques in the middle. These are kind of common techniques that anyone who works in security has probably heard of and maybe tried. These are the techniques I went through. I tried some new things, but my main aim was to do antivirus evasion through the path of least resistance. This is to put the least amount of effort in possible and still evade antivirus. It's quite easy for hackers to get involved in something and be like, oh, I'm writing polymorphic code. My executable changes every time I run it. And that's great, but it's quite a lot of effort, and it's taking away from me actually doing my 9 to 5 of getting access to systems. So I started off with a control executable. My control is Meterpreter. So Meterpreter is a piece of software that comes in the framework Metasploit, and it just allows us command access to a system. We can upload files, download files, execute system commands. I'm using Virustotal as my initial system to tell me whether I'm being picked up by antivirus or not. Virustotal is simply a website you upload a file to. It'll scan it with lots of antivirus, and it'll tell you whether it detects it or not. So my initial thing, Metasploit, Virustotal, didn't actually work out that well, but I'll get onto that. So Meterpreter is picked up as malicious by 34 of 51 antivirus. That's kind of odd anyway, because this is probably the most malicious executable on the planet, and it's only picked up by 34. So evasion's going quite well so far, trying to avoid antivirus, and I've already evaded 17 of them. But this is my control group, it's my baseline. So when we're looking at antivirus and we're analyzing the antivirus system as opposed to the malicious software, because a lot of people do malicious software analysis, but not so many people look the other way. We're told about these things, signature detection. Signature detection is simply the antivirus software is looking at the executable and it's looking for patterns that it's previously seen before that it's being told are malicious, and it'll flag if it sees those. Behavioral analysis is where the antivirus executes the code for a short amount of time and then watches it. Behavioral analysis doesn't necessarily work how a lot of people think it does. It doesn't watch it through its lifetime. Generally speaking, there's maybe a predefined amount of time that it'll watch it for. And if it does something malicious in that time, or it does enough malicious things, then it'll flag it. The third one in here, called pass the sample, is a problem that arose using Virustotal. Virustotal shares samples amongst vendors. So if you upload a control group malware, and then you upload it again several minutes later, your detection rate has increased. Not because they've suddenly seen your code and done deep analysis on that code. They've just said, oh, my friend, the other antivirus solution, detect this, so we probably should as well. And that detection's quite naive, but it kind of alters the data, and it makes doing this scientifically, where we're collecting, oh, this was flagged by this number, that kind of data, it screws that up, because every time I upload it, I get a different number. But antivirus evasion is something that hackers and penetration testers have done for a long time, and there are tools out there that can do it for you. If you Google antivirus evasion, or fully undetectable, FUD, you get lots of tools that can do this kind of thing for you. These kind of tools are closed source binary from hacking groups that we've never heard of, and probably no good thing to run. But this set of tools are open source, they have papers published on them, and they work very, very well. The reason that I didn't want to just use these tools is because my problem with antivirus, or one of my problems, is that it's a black box and I don't really know what it does. If I'm just to immediately take someone else's code, someone else's tool, and apply that, it might work a lot of the time, and in fact these tools do work very, very well. But if it doesn't work all the time, I kind of get stuck. And when I'm stuck, I'm not really doing my job. So these tools implement certain techniques that they document. And the most simple technique, the oldest technique, is to simply encode our payloads. Encoding is taking some data and representing it in a different way. That's all it is. MSF encode is a tool that can do this. And MSF encode was not designed to do this at all. It's designed to alter shellcode, something completely unrelated. But for a small period of time, a long time ago, MSF encode did evade antivirus. And so when you talk to penetration testers or you talk to hackers, it's one of the things they do. They give you this response. Why learn about antivirus evasion when all you need to do is encode? And it totally doesn't work. So I was kind of disappointed when I tried this. So my initial control group, I had 34 detections, and that's a good start. When I encoded, expecting it to drop, it went up. So I got 35 detections. So my antivirus evasion talk's not going well so far, because I've told you exactly what not to do. So I went back to these penetration testers that I know, these black hat hackers, and I said, guys, this technique you gave me totally sucks. The answer that I got, encode more. Just run iterations of the same tool. And indeed, you can run MSF encode with some iterations. So I just put a really big number in there. Here we go. Evasion. Got past 1. We're down to 33. This is progress, right? But what I'm thinking right now is, this is kind of the wrong approach. But I wanted to continue going through that foundation knowledge that was already out there, the things that were already online. There's no point diving into a new area of research and saying, guys, I know what I'm doing. I'll take it from here. We've got to go through what's already available out there. But this quotation, if you can't read it, it's from one of the developers of Metasploit. And he, I guess, is sick of sitting in IRC and saying, guys, MSF encode isn't the way forward. So MSF encode isn't good, but there's other things that we can do. Still sticking within Metasploit and within using Meterpreter as my control group, because I haven't advanced past that at this stage. The way that Metasploit works, and the way, in fact, MSF encode works, is we'll take some malicious shellcode and inject it into a template executable file. The problem with doing that is antivirus vendors, when they're picking up executables, they kind of put in the little amount of effort as possible. So what they do is, instead of looking for malicious behavior, it seems, they just pick whatever is easy to write a signature on. So if all of the malicious behavior that comes from Metasploit, that comes from Meterpreter, goes into this template, why not just flag the template? And that's in fact what they do. So a blank template from Metasploit will get 42 hits. It's 42. This is one of the older templates. It's the x86 template. But they're flagging just what is essentially an empty executable, because they know that no matter what you do, whatever shellcode you inject, it's going to use this template. So one thing that we can do is just use a custom template or use any executable in which we can inject our own shellcode. This isn't a new technique, but I found that even though it's an old technique, it's really effective. I got 4 hits out of 51. But it started to highlight something for me, that antivirus vendors are also looking for the path of least resistance. The thing that I'm trying to do, they're just going with whatever the easiest way to target these malicious executables is. So maybe, instead of doing this crazy new thing and coming up with like zero-day technology, we can just look at what works, get as close as we can to the front lines of antivirus, and make a few changes here and there, a few configuration options. And templates, changing that template really does show that. Continue on from there then, I thought instead of using a template executable and taking a standard executable and injecting shellcode into it, doing the idea of just grabbing shellcode and injecting it directly using virtual alloc or something like that. In fact, there is a Python tool that can do this. Or you can do it with C, literally just create what is essentially a bare bones executable of, here's a variable that holds some shellcode, now fire that shellcode. And it works really, really well. My detection rate came down to 1. So I started talking to people, hackers and penetration testers and saying, okay, this antivirus evasion thing seems really easy if I've already got my detection rate down to 1 using the most malicious executable on the planet. And the answer that I got back from that was that actually Virustotal doesn't really scan your executable all that well. So it looks good when they're saying, oh, we scanned with 51 antivirus engines, but these antivirus engines, they're not deploying the whole artillery. Most of the time, they're just deploying the static analysis parts, the simple parts of it. So these figures don't appear all that accurate, and in fact, you can see that if you create a malicious executable, do the evasion on it, and then upload it to a system that actually runs that antivirus, it might detect it even though Virustotal said that it wouldn't. So my so my scientific approach is failing so far in such that my control group's not all of that good, and also the test cases that I'm getting from Virustotal are essentially lying to me. So I needed to move on from here, and I wanted to get as close as I could to antivirus. Even though they're black boxes, I wanted to set the environment up in such a way that I can extract as much information as possible from that. So the first thing that I did was instead of using Meterpreter as my control executable, I created my own control, and I tried to load in there as much malicious behavior as I could, but to do it in a modular way. So essentially I could turn on and off malicious functionality and try and work out which antivirus vendors are picking up which things. And it turns out that you can get away with an awful lot of stuff without being detected. And most of the antivirus vendors are literally just still working on signatures, and behavioral analysis is still pretty naive and not really that good. What I did is I created what was essentially a real small module that I could deploy to a target system, and then I could fire additional modules at it and look at how the antivirus works. Essentially what I was building here is a botnet. I created this shellcode which is execute on a target system, and then I can listen to that system and see how it reacts in terms of the antivirus. So instead of relying on Virustotal and saying, okay guys, how many antivirus systems pick me up, I created a network of systems, initially starting with virtual systems and then moving on from there during penetration testing on client systems with this code. And I set up my own Virustotal environment. And what this allows me to do is create a malicious executable, fire it at a system, and see if it picks it up or not. So I started doing some things. I got old viruses and took source code from those. I took things that I would want to do as a penetration tester and kind of naively implemented that. So things like the dumping the password hashes from a Windows box and things like that. And in fact, I used tools like fgdump, pwdump, existing tools, and just wrapped them and implemented them in my executable, and then watched how the antivirus system reacted. If I was detected, I played around with that code in naive ways to see if I could get away with doing the activity. And I found that, for example, dumping Windows hashes, the executable is detected as malicious, but it's detected, the signature is on the debug messages, which are there to tell me if it worked or not. But I know whether it worked or not, depending on whether a file's created that contains loads of hashes. So I can go in the source code and I can just remove all the debug functionality, and the executable still fires, it still works, I still get hashes, but the antivirus system doesn't pick me up anymore. So I started creating these test cases where I was like, okay, this exe does something really malicious and antivirus companies aren't picking me up. So I contacted some of the antivirus companies and I told them, I was like, you guys, I can kind of see what you're doing here, path of least resistance stuff, but you're missing a lot of malicious behavior. And they said, okay, absolutely, send us over some EXEs, tell us what it does, and we'll take a look. So I sent over an EXE, and they said, okay, yeah, I can see that we're definitely missing this. So what we'll do is we'll MD5 it, and then we'll pick that up from now on. So maybe that's the wrong approach, and I was talking to some guys last night in the bar thinking, how can we deal with this? So maybe we should just create 200 executables and just keep sending them and see if they're going to keep doing MD5s of those and how long it takes them to give up. But essentially, I think this is the closest that I can get to the antivirus front lines. Antivirus is a black box, and that's generally a bad idea for security. We don't accept this with cryptography. We don't accept just using secrecy with cryptography. So maybe we shouldn't for antivirus as well. Maybe we should move towards more open systems. What I've got set up here is a system that has as many antivirus as I care to deal with, and I can simply drop EXEs on those systems. So the video that's running here essentially showing off how the botnet functionality works. So the right-hand terminal window is the command and control center. The left window handles that GUI, and in the background there's 20 servers that all run a different antivirus system. And when I first showed this to some colleagues, they were saying, oh, how are you wrapping the antivirus to work out whether it detects you or not? And it's really, really naive. I fire a shell at a machine. If I get command line access, the icon goes blue. As long as I have access and it checks every 20 seconds, that machine will stay blue. So I can quite easily deploy these malicious payloads and see if they detect me or not, just based on whether the icon stays blue or not. So what I did was I took all of this malicious behavior and I kind of tried to create my own interpreter. I went with all of the techniques that I would require as a penetration tester or as a hacker to gain complete access to a system, but still trying to implement it in a naive way to see how antivirus reacts. So to go from this, I've now got a really good control. It's open source because it's something that I wrote. I understand it quite well, and I can control the entire environment that these antivirus are running on, and I know whether they detect me or not. So I created an executable which is just clearly malicious. And what it does, the next demo is the exact same thing, apart from this one is trying to show what would happen if a user executed an exe that they shouldn't do. So it sets up the botnet in the same way, but we're now going to jump onto one of these machines. This machine is virtual, and the user is going to execute a file. It could have come from email, could have come from a USB or something like that. And that executable is then going to brute force the passwords of all of the other servers on the network, which is really obvious, trying really silly passwords like password 1. And then if it gains access to that, it'll try and privescope and then fire its shellcode on that box and get command line access. And I kind of expected this not to happen. I kind of expected that it would be really obvious malicious behavior. And that just wasn't the result that I found. So my idea of getting really, really close to antivirus and taking the path of least resistance and getting really close to antivirus worked in so much that I can create a really nice control executable, and I can set up this environment that I can control it really easily. But antivirus evasion isn't that difficult. And so why don't I come here and show you guys something really cool. There's already tools out there that can do this, and it's surprisingly easy to get away with. So this executable, which is firing on the network, it brute forces passwords over the network. It fires malicious executables, dumps password hashes, and then cracks them locally on the target box in the same way that a botnet would do it. So it's connecting to a command and control server. It does a couple of little tricks, like it does stalling code and things like that. And this was actually deployed on the top left box. But if you watch the video, that's pretty much the last box that gets shelled. And that's on purpose. You know, we're hacking other boxes as opposed to our local box. Because if we're going to get detected, we don't want it to be until we've taken over some other machines. But my talk initially was to look at the tools and techniques that we can move forward with. And so this is the new thing for antivirus evasion. And really the techniques that I used was just common sense, getting as much control over a system as we possibly can, and really analyzing the code to see why are we being detected. So take some malicious code, strip it down to the bare bones, and work out which lines we're being pulled on, and then just alter those lines. And a lot of the times, because antivirus companies are going path of least resistance, they're writing signatures for the things that are easy to detect. So MSF encode, that's the technique that I showed initially, doesn't work. And it doesn't work for the quite interesting reason that with MSF encode, all of the data that the antivirus company would need to analyze the behavior of that executable is within the executable. It's not encrypted or anything like that. It's just represented in a different way. But the antivirus vendors don't fire that executable and then watch its behavior because they don't need to. Because MSF encode with the standard encoder has staging code, and they can write a signature for that staging code in the same sense that they wrote a signature for the template. And if you write a portable executable crypter, it's a tool that will encrypt executables, that will have staging code as well. And these antivirus vendors are just picking up on the easy signatures, which means we can also do the thing of just removing those easy signatures. So instead of using Virustotal, instead of using Meterpreter, we can come up with just real simple tools and techniques, things that are more open source, and kind of push the antivirus vendors and say, you know, we're being open, we're evading your system through openness. Maybe antivirus should be more open as well. So black box security is a bad idea, and I think maybe antivirus is the last thing that we've got on our systems which is still black box, and we should probably do something about that. That's my real quick talk, and I've kind of blasted through that far faster than I thought I would. But I'll take questions now. You got another microphone for questions? I'll take that one if it's cables. No problem.
I'm sure you get asked this a lot, but were there any antivirus which were more effective than others?
Not necessarily, and the question that I really get asked a lot is, what is your favorite antivirus? And my favorite as a tester is probably not the same as a person's favorite when they want real security. I like bad antivirus because it makes my job easier. But I really did blast through that content, but the antivirus companies were all picking the content up as malicious for bad reasons, but it was all different reasons. So when I started changing my source code and removing those debugging functionality, it didn't really go from 20 detections down to 0. It kind of like a line change here and a line change there would drop it down, but I got very, very similar results from all of the antivirus companies. And I was talking to someone about that yesterday, about is there really any difference between the AV companies, and should we really have favorites? And it brings up a really odd question of ethics, because if an antivirus company wanted to be the leading company in that area, then they wouldn't really be very friendly to the other companies. And if they found a sample and got a signature for it, or created this really good behavioral engine, they wouldn't share that. But in the interest of good security and everyone being safe, then they should share that.
There perhaps aren't as many AV companies as you might like to think. A lot of the engines are actually shared between multiple different vendors.
Yeah, it's absolutely true. Yeah, a lot of the engines are shared between vendors. And like I say, Virustotal shares samples, and it's quite easy to see that. It's almost immediate. Within a couple of minutes, the detection rate increases for that. So there is sharing between antivirus companies. And I found similar results for all of the antivirus companies. I didn't try them all. I didn't implement the 51 that Virustotal did. I implemented about 15. I showed 20, but there's only about 15 I actually wrote code for. And they all seem to react in very, very similar ways. So the idea of a favorite antivirus maybe isn't something that we could have.
What about existing open source virus? Like you had ClamAV
like
there,
Clam.
for example.
Yeah. I think it's not really... it's difficult. ClamAV is open source, and there are open source security solutions. I think the idea really is to be more public about how detection works. And talking to some people at this conference, actually, who work in antivirus and they work in development. And there's really, really cool things that we can do with antivirus and behavioral analysis and virtual engines and things like that, and emulation. But a lot of that doesn't seem to real world get implemented, and people at home systems and lots of corporations don't implement that. So I think it's not so much just a case of being open source, but it's also being public about the way that we operate, the way that things work.
Do you think it's worth the time and effort to install antivirus software? As a user, not as a security researcher.
What's your threat agent? It's one of those questions with security. It's like, we can evade antivirus, and it doesn't mean that antivirus immediately should go away. It does do good things, and it does prevent old samples and things like that. I don't think, I did a similar talk to this a little while ago where I showed antivirus evasion and like a penetration testing point of view to show our clients, look, we can evade antivirus, isn't that scary? And that blew a lot of people's minds, but really we shouldn't ever rely on one security technique. We shouldn't just rely on antivirus. So I don't think that antivirus should go away, but I think there is a lot of room for it to improve, and I think we should push for it to improve. Shout, go ahead.
In your experience penetration testing, have you ever come across anybody that's detected your malicious software without using antivirus, that's come up with a home solution?
Awesome question. I've come across, working with one client actually, where one of the things that we do is we look to see if they have antivirus installed, and a lot of companies will have antivirus installed on end user devices but not servers, and they call efficiency, and they say, oh, the antivirus slows us down, therefore we don't run it. And I was working with a client once, and I ran some malicious executables on their system, and they weren't detected, so I flagged them in the report as, you don't have antivirus installed. He said, no, we do. And he showed me, and he showed it running with a little icon saying it's fully up to date, and it just wasn't working. And that's the issue of black box security, where we don't really know what it's doing. It makes a loud noise when it finds something, but if it doesn't find something, and we have no idea that it's working at all. I wrote this botnet 9 months ago. One antivirus company has picked it up since, and it picked it up for a really odd reason that I never thought of. It didn't pick up any of the malicious activity, any of the brute forcing of accounts or dropping shellcode or anything like that. What it did pick it up on is the fact that it made itself run on startup, and it detected the persistence. So as an attacker, you don't necessarily require persistence. You might just want to dump passwords and then get out of there. So one AV vendor, I won't name who it is, did pick this up, but they didn't pick it up for the reasons that I thought. But the idea of picking up malicious activity without antivirus is really something that corporations should look at, because it can be quite easy. Well, not easy, that's unfair, but it is something that we can do, I mean. So for example, the second video where we kind of see this exponential growth, where the malicious executable is brute forcing other machines, it does that essentially at random, and then it deploys the same payload to that machine, and we get this kind of exponential growth, which looks really cool in a video. But that is actually quite detectable, because most user traffic, as we know, goes from end user device to server. Something like 80%. It's really, really rare for client machines to talk to each other. So if your network, if suddenly all of your client machines are all battering each other's login prompts, it's probably malicious. I've never had it. I've never had anyone pick up on that, but I guess it's the difference between, do we trust our intrusion detection systems, or do we trust random log checking? You know, the idea of random log checking. And some statistics came out recently from what I've been told, secondhand information, that random log checking is statistically better for security than intrusion detection systems are. 8.5% detection rate to 3.5% detection.
Also, in terms of Linux, Windows, Mac, is there a real difference, or it's just market share?
Another interesting thing that people say to me is, I run Mac, and therefore I can't get viruses. Bring me a Mac and I'll write you a virus, you know? I think, again, the issue is just one of threat agent. Maybe Mac and Linux get less very, very loud malware which spreads across the internet because there's less of those boxes. But if you're targeting a specific company, and I want to say the word APT here, so everyone should take a shot. If your threat agent is APTs, then they probably know the systems that they use. And I find it no more difficult to write malware for Linux boxes as I do for Windows. And in fact, I was really, really lazy on this project, and this runs on Linux because it runs in Wine. Absolutely fine. There's no problem at all. So the shell part of this is running on Windows machines running antivirus, but as you can see, the command and control part is running on Linux, but it's running under Wine. No, you got a microphone. We can start here. We'll move around.
Is there anything you think we as end users can do to open this black box and get vendors to actually, release a little bit more info?
I have very little faith in end users. The problem with end users is that it's this mix of don't understand, don't care, not their field, things like that. And another speaker mentioned the fact that we can have end users do things if we implement fear. But the problem is attackers can implement fear as well. So the few people that I've talked to around camp, I've mentioned the idea of phishing attacks. And we all know about phishing attacks. You send an email to a user and ask them to do something, and then they really shouldn't do that. A recent phishing campaign that I ran, I essentially asked users to give me their passwords, and 63% of users did. And the reason that I feel that worked was because I initially asked them to give me their password under guise of their hierarchy. As the IT director, please give me their password and send it to this Hotmail address. And then I sent a secondary email from a finance director saying, some of you haven't filled this form in yet. Please immediately do so, or disciplinary action will ensue. And it's the issue of end users have two areas in which we work. We have our office systems where we're at work and we presume someone else is going to look after us. And then we've got at home where we've got a very small attack surface anywhere. So I think the best thing that an end user can do is just pay attention to your machine. You spend a long time on your own machine, even if it's an hour a day, that's still quite a long time. When it starts doing weird things, kind of going to notice that. So I think end users are limited because knowledge is limited and effort is limited. But there are things that we can do. It's just keep an eye on our own systems, monitor things. Even if it's naive, something is wrong, I should tell someone something is wrong. The phishing campaign that I ran where 63% of users sent me their password, the 40% that didn't tell anyone. They didn't go, that's a phishing email, I should probably tell someone. So as end users in the workplace, we can protect each other. If one of those users had gone to their IT department or their security department and said, I got a phishing email, that IT department could have blocked the link because every email had the same link. And if they just firewall that, the entire phishing campaign would have failed, maybe got one hit. So in the workplace, we can look after each other. At home, we can just have an appreciation for when things are going weird.
Do you think it's feasible to implement all these advanced detection techniques and be scanning in real time as antivirus does? Is there not a massive system cost for running these things?
If the clients that I already work with don't install traditional antivirus because of performance issues or perceived performance issues, then I would think it would be a hard sell to tell them to actually you need to install more stuff that's going to work harder. I think there's a lot to be said about containerization and this idea where we have virtual environments where we segment applications to just, instead of preventing that initial foothold that an attacker can get, to simply prevent them pivoting across the systems. That can be localized with every application running in a sandbox, or it can be network-wide where the worm demo is a naive demo where the malicious software brute forces those passwords. If there weren't weak passwords, then you've entirely stopped that propagation anywhere. So maybe there's not a lot we can do for initial foothold, but maybe there's a lot we can do in terms of monitoring and preventing propagation. Yeah, it is true to say we can do more in terms of behavioral analysis. Behavioral analysis is probably really hard. I don't write antivirus. But I think there is probably more we can do in terms of virtualizing systems and having a better view of the way that the executables are running. There was a recent DEF CON talk actually where somebody was talking about that, emulating systems as opposed to virtualizing them to get more view of what's going on.
So 10 years ago, we deployed a behavioural system across a 60,000 user estate. We got about a 5% hit on individual systems. They were both desktop and server. The interesting bit was we spent about 2 million on the software. But we had to sort of treble the size of the team that were just looking at the logs. The problem with behavioural systems is actually you need people to go through and look at the logs. The systems can't.
Not only that, but the issue with behavioral analysis as opposed to static analysis is static analysis is a Boolean. I've seen this before. It has previously been proven to be malicious, and therefore I can flag it. With behavioral analysis, it's the idea of it doing enough bad. So when we're looking through logs, something weird happens, and it's like, is that weird enough that it's malicious, or is it just an anomaly? So you're absolutely right, with behavioral analysis there is increased manpower required or increased processing power.
But we caught shit. The interesting thing is I work as a penetration tester now, and I've not seen any of our client base, big or small, deploy anything like that. So there's not, it's a one-off in 10 years of pen testing.
Yeah. As a pen tester, we don't really have that much difficulty evading antivirus, and I find that a curiosity enough to stand in front of you guys and say, why doesn't antivirus work?
As a pen tester, what's your view on default permit versus default deny? As in, if you have a client with, say, an important server that is highly exposed to the net, to simply whitelist all the exes that you actually know should ever be running, and then if they say install something new, they can add it to the whitelist, rather than saying everything can run, and let's hope that nothing malicious ever comes on here.
Yeah, the problem with that kind of security, it's like we have this idea where as soon as somebody proposes a solution, people will just nitpick at it, and it doesn't necessarily mean that it's bad. But we should do something. To whitelist executable still has the issue of if you inject shellcode into that process, then you're running as that executable and therefore can get around it. But if you have the manpower to do that, if you have a system that scope is narrow enough that we can whitelist executables specifically, then that totally works. Say again?
Every office needs Word. If you allow Word, you allow macros. It's game over, so whitelisting's not going to be an effective solution on its own.
That's true, and the same with dropping shellcode into processes anyway. It's not a cure. It probably helps, but it's not a cure. And it depends if the threat agent is someone sitting behind. If I'm sitting on the command and control server, then I can direct the shells and I can direct the bots to do things. If they're spreading like a worm spreads and it's just naively outwards, then maybe it does assist.
Do you think using things like process hacker, like task managers and sandboxing, does that work just on a software level, sandboxing, or do you need hardware as well?
No, I think on a software level that it does work. I saw something cool actually. There's a project where someone has implemented Virustotal within Task Manager. So if you open Task Manager, it'll fire those executables to Virustotal. And okay, Virustotal is naive, and I showed that previously. But again, it's something quite cool to say that I can quite easily just fire executables up. But no, sandboxing is a really cool thing in terms of the issue of propagation. So okay, I might be able to jump into that process or into that small virtualized instance. But if I can't get out of that, or if it doesn't have any interesting permissions, then maybe we give the attacker the initial foothold, knowing that we can prevent propagation. I think so. Maybe it depends how much manpower you've got. Yeah, I tried to compile a list of malicious behavior, and I started out with something like 12 things that I thought would be malicious, like dumping password hashes and things like that. And my list now is something like 220 things that I can think of that are malicious. That kind of thing does work if you can spot it and if you have the ability to go in there and look at it. The problem is some of the malware, the activity that it does is it really doesn't look that malicious. So the most simple foothold an attacker can have is simply an executable which reads from the network and pushes it to cmd.exe. So reading from the network and running an executable in the system which is there by default, to spot that behavior is quite difficult. I mean, you can automate that. If network packets immediately come in from the network and are immediately pushed to cmd.exe, then that's malicious. But as a human being, I think we would miss that.
You were saying you wanted antivirus companies to open up a little bit about how they do detection. Do you think that carries an increased risk that then malicious individuals could exploit weaknesses that they see in those?
The parallel that I drew, and it's a naive parallel, is that of cryptography, where we don't accept secrecy in the world of cryptography. Our algorithms are open, but our keys are not. And that's the parallel that I drew to say that maybe antivirus should be open because security. I don't generally expect antivirus companies to go, you're right, we should do this, because they have the whole sales thing, don't they, where they like to spin things to show that they are the best. And I think that's interesting, both in ethics and the way that it works, where people still ask, what's your favorite antivirus? It's like, well, kind of all the same to me.
In the net where you're basically finding the user account passwords,
Yeah.
were that local user accounts? And if so, have you encountered situations where there's all local accounts are disabled, and you're talking like a domain situation?
Yeah.
How does that compare?
The reason that I did this is because it's quite a common thing as a penetration tester for us to do. If we have physical access to a device, then we can dump the local passwords. Local admin password of lots of machines is a huge risk, and lots of companies don't realize that. Because a lot of companies will protect domain administrator accounts and kind of forget about local administrator accounts. There's progress being made in this area. So one thing we can do is we can dump the hashes and then log in using pass the hash, where instead of cracking it, we just log in using it. And a recent Microsoft patch changed that so that local admin accounts that have been added can't log in with a hash. It's only the default ID 500 that works with. So progress has been made, but password reuse is a bad thing and we know it, but it's still prolific. And local admin accounts, if they're not needed, then they should be turned off, in the same sense that anything that is not needed should be turned off. We reduce our attack surface massively just by turning things off and uninstalling things that we don't actually need. a really good example of something which is installed on a lot of systems by default is Tomcat. Tomcat comes bundled with things, and administrators don't necessarily know what it is, but it's one of my favorite ways to get into a system is to brute force Tomcat.
You said you don't care about the vendor of the antivirus. Do you see a difference between the so-called free for personal use and the professional versions?
I tried not to draw a difference between free and paid for, and I did that on purpose because I was curious to see if there would be a difference. During my 9 to 5, I see the paid for ones because corporations get that warm fuzzy feeling when they've paid for something. But I didn't see that much difference between the antivirus aspect of free and paid for. I think the engines were very similar. From my experience, what I see is you tend to get, oh, the free version is just antivirus, but the paid for version is antivirus and anti-spam and firewall, and it's a bundle, the kind of 360 security type thing. So no, I didn't see a difference between paid for and free. I think we're done. Thanks, guys.